resistance of a cylindrical capacitor, right? Cylindrical capacitor, right? And we'll also be doing one problem related to capacitance. Okay, see, we have our cylindrical capacitor. Something like, right, uh, the radius of the inner cylinder, just let's say this radius is r1, for the outer one this radius is r2, right? And length of our cylinder is L, right? Now the inner cylinder, let's say this, we have given it a charge q. Okay, since it is a conductor, so charge will be distributed on the surface, right? And the opposite and facing surface will have equal and opposite charge, negative charge. This is q and this is I. Okay, now the electric field due to this charge, this surface will be in this direction, right? In the outward direction. Okay, now if you see that electric field between the cylinder will be what? Electric field between cylinders, it will be, I have told you in electrostatic you have founded that electric field due to hollow cylinder, it will be lambda upon 2 pi epsilon naught r. Lambda is what? It is your linear charge density, LCD, right? Charge density, okay, that is q by L. Okay. So you can also write it as E is equals to q upon 2 pi epsilon naught r L, right? We have substituted lambda q by L in place of lambda. Okay, now if the potential of this surface is, you consider V plus, okay, and potential of this surface, the outer one, if you consider at V minus, okay, then what will be the net electric potential between them? Sorry, what will be the net electric potential difference between them? Okay, it will be V is equals to V plus minus V minus, right? And this will also be what? Minus E dot dr, and R is varying from R2 to R, right? So you can write V as minus, and we have derived what is E. E is actually Q upon 2 pi epsilon naught R L dr, right? And from R2 to R. Okay. Now we will take common terms out. So Q upon 2 pi epsilon naught L. We'll take it common, and 1 dr upon 1 by r, integration of that will be ln of r from R2 to R1, right? From here we will get V as minus q upon 2 pi epsilon naught ln of R1 by R2, or you can write it as q upon 2 pi epsilon naught L ln of R2 upon R1, right? Now we have derived the potential difference. Now we just need to apply the simple formula q c is equals to q upon v. Then we'll put the values and we will get c as 2 pi epsilon naught L upon ln of R2 upon R1. This is our capacitance for cylindrical capacitor, right? So we have derived for parallel plate capacitor, okay, for cylindrical, for spherical, okay, right? So yeah, that's it. Now we'll do one problem related to capacitors, okay. Suppose the problem is we have an identical charge drop, okay, an identical charge droplets, okay? Each having potential V naught, right? They coalesces to form a big drop, okay. They coalesces to form big drop. You have also done this type of problem in, I think, +1 in fluid mechanics, right? So yeah, each having potential V naught and they coalesces to form a big drop, okay. And if capacity of each small drop is C naught, means if you consider these small droplets, okay, they are having capacity C naught, okay, then we need to find the potential of big drop, okay. If they coalesces to form, let's say, big drop, okay, then we need to find it, okay. Now if you see that we have n droplets, right, first you try pausing the video for on your own self and then match the answer, okay. You have n droplets, okay, each having radius r, right, small r, okay. Charge is q naught, okay. These are the things that are given, okay. Charge is q naught. Now the capacitance is also given, that is C naught, okay, and potential is given as V naught, okay. Now what will be the relation between Q naught, C naught and V naught? It will be Q naught equal to C naught into V naught, and you know C naught is equals to 4 pi epsilon naught R, right? Because each one having charge, they all are spherical drops, okay. Now I'm doing it for the smaller one, okay. Now you know that volume will be same, n into 4 by 3 pi r cube is equals to 4 by 3 pi capital R cube if you consider the volume of this as capital R, okay. And volume of these smalls will be, oh sorry, radius of these will be smaller, okay, and radius of the bigger one as capital R, right. So from here you will get R cube is equals to capital R cube upon n. So R is equals to capital R upon n power 1 by, right. Now looking at the bigger drop, okay, see Q will be n into Q naught because we are coalescing all the charges, so charge will be added, okay. The charge on this sphere, okay, let's say this is C, Q and V, okay. So C will be 4 pi epsilon naught R, okay. C will be 4 pi epsilon naught, and you can write capital R as small r n power 1 by 3, right. So from here you will get C is equals to C naught n power 1 by 3, because this term 4 pi epsilon naught R can be written as C naught, okay. So our question is done. V will be Q by C for the bigger one. So V will be, you can write as Q naught n in place of Q, and in place of C you can write C naught n power by 3. So from here V will be Q naught by C naught is V naught, and this will be n power 2 by, this will be your electric potential of the bigger drop, okay. And V naught is what? Or from here V naught is our potential of the smaller drop, right. This will be the potential of bigger. Thank you. From onwards we'll be studying series combination of capacitors, parallel combination and other things. you need to keep practicing the problem. Okay,